Hello everyone, welcome to today's lecture on energy performance matrices and indicators. My name is Purvi Chandrakar and I am thrilled to guide you through this exploration of energy efficient buildings. In the previous lecture, we have already learnt about heat exchange in buildings, factors influencing building energy performance, analysis of building energy use performance, and now in this lecture we will learn about energy performance indicators, that is EnPIs, types of energy performance indicators, benchmarking industrial energy performance, introduction to ISO 50001, energy performance indices for buildings, benefit, challenges and practical applications of EnPIs. Now let us begin. Energy performance refers to measurement and assessment of how efficiently a building or system uses energy resources to achieve its intended function, such as heating, cooling, lighting and operating equipments. Importance of energy performance. Efficient energy performance is crucial for reducing operational cost, minimizing environmental impact such as greenhouse gas emission and ensuring sustainability. It also plays a significant role in meeting regulatory requirements and improving occupant comfort and productivity. Matrices and indicators. Energy performance is often quantified using matrices such as energy use intensity EUI, which measures energy consumption per unit area or activity, and various energy performance indicators like asset rating, operational rating and energy service index ESI. These indicators help assess performance relative to benchmarks or standard. Factors influencing energy performance. Several factors influence energy performance, including building design, construction materials, HVAC, that is heating, ventilation and air conditioning, system efficiency, occupant behavior, operational schedules and external environment conditions such as climate. Role in building design and operation. Energy performance considerations are integral during both building design and operation phases. Design decisions impact long-term energy consumption, while operational practices and maintenance affect day-to-day efficiency. Effective energy management involves optimizing both design strategy and operational practices to achieve desired performance outcomes. What is energy performance indicator, that are EnPIs? EnPIs are quantitative indices that measure an organization's energy performance. They allow for comparison over different periods, helping to track improvements and identify areas needing attention. In 2011, ISO defined EnPIs, and in 2018, they revised the guidelines to emphasize accurate energy measurement. EnPIs are crucial for making informed decisions about how to enhance energy performance, taking into account various factors such as productivity, equipment lifespan or even weather patterns. Importance of accurate EnPIs. Accurate EnPIs are essential for several reasons. They provide a realistic and objective estimate of your site's energy performance, guide decision making regarding resources and investment, and help internal and external sustainability goals. Moreover, they are necessary for compliance with standards like ISO 50001, which require organizations to demonstrate continuous improvement in their energy performance. EnPIs also allow us to detect unexpected deviation, identify savings opportunities and make strong case for further investment in energy efficiency projects. Key functions of EnPIs. EnPIs serve multiple critical functions. They give a realistic view of energy performance and support informed decision making regarding resources and investment. They also help in accessing compliance with sustainability commitments and identify deviation to avoid energy waste. Additionally, EnPIs can detect periods of better than average energy performance, estimate cost savings and establish benchmarks for industry, regional or national standards. This makes them invaluable tool for pitching new energy efficient projects and rallying for more investments. Types of EnPIs. There are various methods to determine EnPIs, each with its own level of complexity and accuracy. These include theoretical estimates and assumptions, simple absolute energy consumption which does not consider any variables, specific energy consumption which consider only one variable, regression analysis which normalizes energy performance by accounting for multiple variables, sophisticated technical modeling requiring specialized softwares, signs that need to improve EnPI approach. How can you tell if your EnPI approach needs improvements? Here are some signs. Your energy performance accounting process hasn't been updated in years. Unsure which variable affect your plants or buildings' energy performance. You cannot clearly see the impact of your energy efficiency measures. You are not routinely monitoring performance or reacting to deviations. Your energy performance indicator graphs require a lot of interpretations. Safety incidents and equipment failures are happening more frequently. If any of these apply to an organization, it's time to rethink their approach to EnPIs. Benefits of improved EnPI. Improving EnPIs can unlock significant potential energy savings. Accurate and carefully considered EnPI can provide a more detailed understanding of our energy system, enabling identification of new saving opportunities. They ensure more consistent and reliable data for better business decision and allow for better forecasting of energy demand. Improved EnPIs also facilitate faster response to deviation and enhance predictive maintenance, reducing the need for external consultants. Additionally, they prepare organizations for ISO 50001 certification and support the growth of local energy service companies. Benchmarking industrial energy performance. While EnPIs compare an organization's performance over time, benchmarking involves comparing energy performance across different sites or industries. For instance, Canada's Office of Energy Efficiency benchmarks various national industries, and the Netherlands encourages companies to aim for the top 10% in energy efficiency globally. In the US, Energy Star provides a tool for benchmarking industrial plant energy performance, and Lawrence Berkeley National Laboratory offers a benchmarking tool and a energy saving tool. Benchmarking helps set industry standards and encourages organizations to strive for best practices in energy efficiency. Now, limitations of benchmarking. Benchmarking is not without its challenges. It's complicated by the array of variables and methods used to assess EnPIs and by issues of data confidentiality and sensitivity. These factors can make it difficult to set industry-wide standards and policies. Despite these limitations, benchmarking remains a useful tool for setting goals and promoting energy efficiency improvements. It's important to approach it with an understanding of its complexities and limitations. Practical step for implementing EnPIs. To implement effective EnPI, start by establishing baseline data and reference periods. Choose appropriate EnPIs and methodologies such as regression analysis to ensure accuracy. Regularly monitor and update the EnPIs to reflect any changes in operation or external factors. Train the staff on the importance of EnPIs and integrate them to the decision making processes to ensure that energy efficiency remains a priority. So, we have discussed the importance of energy performance indicator and how they can transform energy management. Accurate EnPIs provide the foundation for continuous improvement and help organizations meet their energy efficiency goals. Remember, improving EnPI approach can lead to significant benefit from cost saving to better compliance with standards like ISO 50001. Now, let us explore the implementation of ISO 50001 energy management practices and how they can help achieve a systematic energy performance improvements. Introduction to ISO 50001. ISO 50001 is a comprehensive standard for energy management systems. First, introduced by International Organization for Standardization in June 2011. It emphasizes on systematic approach to improving energy performance with a key focus on using energy performance indicators or EnPIs to track progress and drive continual improvement. Key components of ISO 50001. ISO 50001 outlines several key components for effective energy management. These include adopting an energy policy at executive management level, creating a cross-divisional management team led by a representative who reports directly to top management, undertaking an energy planning process that includes an energy review, establishing baselines for organizations' energy use, tracking energy performance indicator against these baselines to measure progress. Energy policy and management team. An executive level energy policy sets the tone for organizational commitment to energy management. A cross-divisional management team with a representative reporting to top management ensure that energy management efforts are well coordinated and integrated across different functions and departments. This structure supports effective decision making and accountability. Energy planning and baselines. Energy planning involves conducting a thorough energy review to understand current energy use and identify opportunities for improvement. Establishing baseline is crucial as they serve as a reference point for measuring future energy performance. These baselines allow us to track progress and identify trends over time. Tracking energy performance indicators. Tracking EnPIs is essential for measuring improvements in energy performance. By comparing current performance against the baseline, we can assess whether we are meeting our energy goals and identifying the areas needed attention. Selecting the right EnPI is critical to ensure accurate and meaningful measurement. Setting objectives and targets. ISO 50001 requires organizations to set energy objectives and targets for improvement. These targets should be specific to relevant functions, levels, processes or facilities within the organization. Action plan should be developed to meet these targets, ensuring that all aspects of the organization are working towards continuous energy improvement. Operational controls and procedures. Operational controls and procedure must be established for significant energy uses to ensure that energy management practices are effectively implemented continuously monitored and documentation are necessary to track performance and identify areas for further improvement. Continual improvement and reporting. ISO 50001 emphasizes continual improvement in energy performance. Regular reporting of progress to top management is crucial for maintaining momentum and ensuring accountability. Based on performance data, we should continuously refine our plans and targets to drive ongoing improvements. Selecting and measuring EnPIs. Selecting and measuring EnPIs involves choosing indicators that addresses both physical changes to the building and operational effectiveness. These indicators should be tailored to the specific context of the organization and reflect the full range of issues that energy managers must address. A comprehensive approach ensures that we capture all relevant aspects of energy performance. Practical step for implementation. To successfully implement ISO 50001, organization should follow practical steps such as creating comprehensive energy management plan involving all relevant stakeholders and setting up effective monitoring and reporting system. Examples of successful implementation can provide a valuable insight and guidance for our own efforts. So, such examples of successful implementation should be given to the management team. Benefits of ISO 50001 implementation. Implementing ISO 50001 offers numerous benefits including enhanced energy performance, cost savings, improved operational efficiency and reduced environmental impact. It also helps organization comply with regulations and standards, strengthening their market position and reputation. So, to conclude, ISO 50001 provides a robust framework for systematic energy management. By focusing on continual improvement and effective use of EnPI, organizations can achieve significant energy performance improvements. I encourage you to consider adopting these practices to enhance your energy management efforts. Now, let us delve deeper into various forms of EnPIs used globally to evaluate and monitor building energy performance. Let us explore how these matrices can guide effective energy management. Introduction to Energy Performance Indices (EnPIs) for buildings. EnPIs are essential tool used worldwide to assess the energy performance of buildings. They inform critical decisions during the entire life cycle of a building, from design and construction to renovation and operation. Accurate EnPI provide the quantitative foundation that is needed for effective energy management. Importance of quantitative measurements. Building energy performance is influenced by three key factors, that is engineered system, operation and management practices and the third, occupant behavior. To fully capture the complexity of these interactions, we need at least three distinct EnPIs. Simplified to a fewer indices may overlook important aspects of energy performance, hence we need a few more indices. ISO 50001 and EnPIs. ISO 50001 outlines how EnPIs can track progress towards specific energy goals. Effective EnPIs provide a clear feedback on the effectiveness of energy management plans, helping organizations make informed adjustment to their pre-existing plans. In contrast, ineffective EnPIs can mislead by not accurately reflecting true improvements or declines in performance. Dimensions of building energy performance. Energy performance in buildings hinges on three dimensions: the design and construction phase, which set the baseline efficiency; second, online operational and maintenance practices, which can enhance or degrade the performance; and the third, occupant behavior, which dictates energy service levels. Managing this aspect effectively required targeted EnPIs. Defining energy efficiency. We defined energy efficiency as delivering consistent energy services while using less energy. This definition aligned with major studies and distinguished efficiency improvements from energy conservation, which can include reducing service level. This means the energy efficiency improvement and energy conservation both are completely different topics. Focusing on energy efficiency means we maintain service quality while cutting energy use. Types of EnPIs. There are 4 types of EnPIs. First, asset EnPI or asset rating. Second one is operational EnPI, or we can call it operational rating. Third, O&M index or operation and maintenance index. And the fourth and last one is energy service index. Let us now discuss all these types of EnPIs one by one. First is asset rating. Asset ratings are evaluation of buildings' energy performance based on simulated energy consumption. These simulations take into account the building's physical characteristics like the wall, windows, areas, thermal conductance and efficiency of system. The purpose is to provide a standardized way to assess the energy efficiency of a building by isolating it from variation in operation, maintenance and energy service demand. The formula for an asset rating equal to asset EnPI, these are the same thing, is equal to EP RB, Ni divided by EP BB, Ni, where EP RB, Ni is the energy performance of the rated building determined from the energy model. The Ni subscript means that a neutral independent modeling assumptions are used. Similarly, EP BB, Ni is the energy performance of the baseline building determined through the same modeling procedure. The same neutral independent modeling assumptions are used as for the rated building. Second is operational rating. Operational ratings are matrices that assess buildings' energy performance based on actual meter energy consumption over a defined period, typically about a year, and adjusted for factors like occupancy, weather and floor area. They are used to compare a building's energy usage against a baseline of similar buildings to gauge its efficiency relative to peers. Operational rating formula. The formula for operational rating is EP RB, EB divided by EP BB, AEB, where EP RB, EB is the energy performance of the rated building derived from utility bills, and EP BB, AEB is the energy performance of the baseline buildings adjusted for the rated buildings condition. The third is operational and maintenance index, that is O&M index. The O&M index compares actual energy use to modeled performance, adjusting for operational realities. O&M index is the ratio of actual energy use to the modeled performance, adjusted for actual condition. The formula for O&M index is EP RB, EB divided by EPRB, ND, where EPRB, EB is the energy performance of the rated building determined from the utility bills. Electricity, gas and other fuel measured at the meter would be converted to common units, and EPRB, ND is the energy performance of the rated building determined through modeling, but the actual operating conditions of the rated buildings, that is neutral dependent or ND. Fourth one is Energy Service Index. The Energy Service Index measures energy efficiency at observed service levels against standard benchmarks. Energy Service Index is the ratio of energy performance at observed service levels to standard service level. That is, the formula for Energy Service Index will be equal to EPRB, NI divided by EPRB, ND, where EPRB, NI is the energy performance of the rated building neutral dependent. This is the actual energy performance of the building under its current operating condition, whereas EPRB, ND, that is energy performance of the rated building with neutral independent. This is the energy performance of the building based on standard conditions used for the asset rating. Now, if ESI is less than 1, it indicates that the actual energy services demanded by the building are less than those assumed in standard condition for the asset rating. The building's actual energy use is lower than expected under standard condition, which is very good. If ESI is greater than 1, it indicates that the energy services demanded are greater than those assumed in the standard condition for the asset rating. The building's actual energy use is higher than expected under standard condition. And if ESI is equal to 1, it indicates that the building's energy use under actual condition is the same as it would be under the standard condition used for the asset rating calculation. After the types of EnPIs, let us now understand the difference between asset rating, operational rating and the O&M index. The table shown in the screen, this table summarizes key difference between asset rating, operational rating and the O&M index for a typical building. Benefits of EnPIs. EnPI offer a comprehensive view of energy performance, helping to identify opportunities for improvement across different dimensions. They facilitate effective energy management by providing actionable insights into design, operation and occupant behavior, supporting continuous performance enhancement. Challenges in EnPI selection. Choosing the right EnPI is the challenging task due to the lack of clear guidelines on their optimal use. There is a need for a robust framework to test the effectiveness of various EnPIs scientifically. Ongoing discussion and data analysis are crucial for refining these matrices and improving their application. Practical application of EnPIs. EnPIs can be applied to monitor energy efficiency, assess operation and maintaining practices, and understand occupant energy demands. They are valuable in various building types and scenarios, helping to achieve the goals outlined in ISO 50001. Effective use of EnPI also supports continuous improvement in anyone's energy performance. Summary. So, in conclusion, EnPIs are vital tool for effective energy management helping to maintain improved building energy efficiency performance. Implementing a well-structured EnPI framework ensure better decision making and significant energy savings. I encourage you to leverage these matrices for sustained energy efficiency in your building. In the upcoming lecture, we will discuss microclimate considerations in building design, strategies for achieving thermal comfort and integration of thermal comfort in energy efficient building design. Thank you and wish you a very happy learning.